Welcome to the Deep Dive. Today we're getting into something pretty mind-bending. Objects from outside our solar system. Not just, passing through, but maybe carrying secrets.
It's a fascinating possibility.
We all remember Oumuamua, right?
Yeah.
That really strange visitor a few years back that just blew past us.
Absolutely. It challenged a lot of assumptions.
And it wasn't the only one. We've seen other interstellar objects, ISOs, and they've been surprising too.
They really have. These visitors force us to ask some pretty big questions.
Right. So for this deep dive, we want to explore the science of technosignatures. How are astronomers actually looking for signs of alien tech inside these ISOs?
Yeah, exactly. And what's really cool is that it's often not about building, entirely new giant telescopes.
Oh, really?
Yeah, it's more about finding clever ways to analyze the data we're already getting, sharpening our focus with each new object we spot.
Okay, so it's like a cosmic detective story happening right now. We're digging into that fundamental question. Are we alone? And could the answer, literally fly past us? Maybe even right now.
It's a definite possibility, a fleeting glimpse, perhaps.
It really makes you think. Okay, so let's unpack this. When we talk about hunting for alien tech in these ISOs, it's not just pointing a telescope and hoping. You need to know what you're looking for. What counts as unnatural. So if some alien civilization did send a probe, what clues would give it away?
Right. That's the key challenge and the opportunity. The first major clue would be in its light signature, what we call unnatural spectra.
Okay, spectra. Explain that a bit.
Natural things, asteroids, comets, bits of rock and ice formed naturally. They reflect and absorb light in predictable ways based on their chemistry.
Like a fingerprint.
Exactly. Chemical fingerprints. We have a pretty good handle on what those natural signatures look like. We know what elements are common out there, how they behave.
So how would an artificial object look different in that light?
Well, think about it. An alien probe, maybe with engineered surfaces, special coatings, maybe even, windows. It could reflect light in ways that just don't match natural materials. You might see combinations of elements or types of materials that, shouldn't exist on a random chunk of rock.
It would just stand out.
It would really stand out under spectral analysis. It'd be like finding, stainless steel in a sample of moon rock. You'd know it wasn't natural.
Okay, that makes sense. What else?
Even more telling could be infrared emissions. Heat.
Heat? From an object in deep space.
Exactly. Space is incredibly cold, right?
Wow.
Near absolute zero, mostly. So if an ISO had, say, onboard computers, maybe a small reactor, some kind of active tech,
It would be giving off heat.
it would radiate more heat than a dead rock warmed only by the distant sun should. It creates what we call an excess thermal signature.
And that would be a red flag.
A huge red flag. An immediate sign that something internal is generating energy.
But how sure could we be? It's technology, not just some weird natural process we haven't seen before.
That's always the question. You have to rule out the natural explanations first. We calculate how much heat an object should have based on the sun, its size, its spin.
A baseline.
Right. An excess is a clear deviation from that baseline. Now, to be clear, the ISOs we've seen so far, all three of them have shown pretty normal natural spectra and heat profiles.
Okay, so no smoking gun yet.
No, but each one helps us refine what normal looks like. So we're better prepared to spot the abnormal when or if it comes along. We learn with each pass.
Okay, so beyond what they're made of, or if they're warm, what about just their shape?
Yeah.
That seems like a big one.
It absolutely is.
You mentioned our own ideas for space travel, like solar sails.
Yeah.
Those huge, thin sheets pushed by sunlight.
Right. That's the second major clue. Unnatural shapes.
Sure.
If we saw an ISO that was, say, very flat and wide, like a sail, or maybe had sharp geometric angles.
Something clearly made.
Yeah, something that's really hard to explain through natural collisions or formations. It would be a very strong hint.
But how do we even see the shape? These things are tiny and far away, right?
They are. Usually we can't get a direct picture. We can't resolve the shape visually.
How do we know?
We infer it, mostly from how its brightness changes as it spins or tumbles.
Ah, okay. Like if you spin a pencil, the light flashing off it changes differently than if you spin a ball.
Exactly like that. A long, thin object tumbling end over end gives a different pattern of brightness fluctuation than something roughly spherical.
But couldn't natural things mess that up, make it look weird?
Oh, definitely. That's the complication. Natural processes like tumbling erratically, or the slight push from sunlight itself, radiation pressure can affect the rotation,
Right.
especially on a lightweight object. Or if it's outgassing, like a comet, that can make it spin unpredictably too.
So it's hard to be sure if a weird spin is natural or engineered.
It can be tricky to disentangle.
Oh.
But the potential is there. Imagine spotting an ISO that's clearly flat, maybe rotating in a really stable, controlled way, unlike a chaotic tumble.
That would be compelling, especially if it looked like our own sail designs.
It would certainly make you think, could that be the first undeniable sign of alien design? It's a tantalizing thought.
Okay, we've got strange light, unexpected heat, maybe impossible shapes. But what's the ultimate proof? The kind of evidence that leaves no doubt?
The gold standard.
Yeah, what would that be?
That would have to be alien transmissions, a direct signal. That's the most decisive technosignature you could hope for.
Like radio waves or lasers.
Exactly. You know, the SETI program Search for Extraterrestrial Intelligence has been listening for signals like that from distant stars for decades.
Right, scanning the skies.
But the huge advantage with an ISO is that it's here.
Yeah.
Inside our own solar system. It's vastly closer than any star system SETI is usually listening to.
So the signal wouldn't have to be as powerful.
Precisely. Even a relatively weak signal, something not designed to cross light years, but maybe just for, say, local communication or data transmission.
We might actually pick it up.
We'd have a much, much better chance. Imagine catching a radio whisper from something like Three-Eyed Ellis, another ISO we saw. Or maybe detecting a focused laser pulse flicking across space from one of these objects.
Wow.
That would be incredibly hard to explain away naturally. It'd be near certain proof of technology.
Proof that we're not alone. That would change everything overnight.
Absolutely everything.
And what's really exciting, you mentioned this earlier, is that astronomers don't necessarily need entirely new gear for this specific search, right?
That's one of the best parts, practically speaking. We can leverage what we already have.
So the telescopes looking for planets or mapping the sky?
Exactly. Things like Pan-STARRS, which found Oumuamua, or other sky surveys, and deep space telescopes, they're already collecting the kind of data we need. Light curves, spectra, thermal readings.
It's just a matter of looking at that data with this specific question in mind, applying these checks for technosignatures.
Pretty much. Refining the analysis techniques, knowing what anomalies to hunt for. It's about using existing power more effectively, which is great. We're maximizing the return on investments already made in astronomy.
Are there plans for, like, dedicated missions, though, to go look?
Oh, people are definitely thinking about it. There are proposals, concepts for future missions, interceptor missions, actually.
Interceptor, like chase them down.
Yeah. The idea is to launch a spacecraft rapidly to rendezvous with a future ISO after it's detected entering the solar system, to actually get up close, maybe even land a probe.
Wow, like Rendezvous with Ramos?
Uh?
Arthur C. Clarke stuff?
Exactly. It's pure sci-fi territory, but scientists are seriously sketching out how it might work. It shows you how captivating these objects are.
Are these funded? Are they actually going to happen?
Well, they're still concepts, unfunded for now. But they absolutely reflect the scientific imagination and, frankly, the hope associated with ISOs. The potential payoff is just enormous.
Sending a probe to an alien artifact, that would be the ultimate deep dive.
It really would. And think about the patience involved if someone is sending probes across interstellar space.
Millennia in transit. Maybe longer. Incredible.
And the search itself is about to get a huge boost. There's the upcoming Vera Rubin Observatory.
Oh, yeah, I've heard about that. Big new survey telescope.
Massive. It's expected to find maybe 50 or more ISOs over the next decade or so.
50. Compared to the 3 we know now.
Exactly. It'll completely change the game. We'll go from a few tantalizing glimpses to a real population study.
That's huge.
Each new one helps us build a better picture of what's normal for interstellar debris. And that makes it much easier to spot something truly abnormal. We'll know it when we see it, hopefully.
You know, these ISOs have already made us rethink planetary formation, how stuff gets ejected from star systems, basic astrophysics.
They really have shaken things up.
But the search for technosignatures, that takes it to a whole other level, doesn't it? It's more than just science.
Oh, absolutely. It gets philosophical, even existential very quickly. What's fascinating and maybe a little unnerving is thinking, okay, what if one is artificial? What does that actually imply?
Right. What would it be?
Would it be an active probe like scouting, or maybe just derelict, an old ship, a piece of space junk from another civilization tumbling through the void?
A ghost ship.
Or maybe even a message carrier, something deliberately sent. carrying information, maybe in its structure, maybe in stored data.
A message in a bottle, thrown into the cosmic ocean.
It opens up so many possibilities.
Yeah.
And they all force us to reconsider what might be out there.
And the implications, I mean, it goes way beyond just, we're not alone.
Way beyond, because if civilizations are sending artifacts across the stars, what does that tell us about them, about their intentions?
Are they explorers? Colonizers? Just curious.
We'd have no way of knowing initially. It raises really fundamental questions about our own place, doesn't it? Our significance or maybe insignificance. And it makes you, everyone listening, think, what would that discovery actually mean for us? For humanity?
How would we react? Would it bring us together? Freak us out?
Who knows? It's a scenario that could shift our entire worldview overnight. And it's not purely theoretical anymore. It's something astronomers are actively looking for.
So as more of these interstellar visitors are found, and we study them more closely, the chance remains. One of them might just carry those first, undeniable signs of technology from somewhere else.
It's an ongoing watch. A patient search.
Looking for that cosmic needle in a haystack?
Until then, yeah, astronomers are ready. Telescopes pointed, algorithms running, constantly refining the search, asking that very human question.
Are we alone?
Or are the answers just drifting through our cosmic neighborhood, one strange visitor at a time? It really is a treasure hunt on the grandest scale.
Definitely something profound to think about next time you look up at the stars.
Yeah.
We hope this deep dive has sparked your curiosity about these incredible objects and the search for answers. Stay curious, and we'll see you next time.